Very good morning to one and all present here. Today, I'm going to discuss very important topic as an exam point of view. Okay, that topic name is R and S configuration and quick review. Myself, Dr.J.Karthikeyan, Associate Professor and Head Department of Chemistry, Satyabama Institute of Science and Technology. Now we'll start with the basic principle behind the periodize. Okay, what is that? Con in gold log rule. So how you are going to periodize? The atoms or functional groups are present within the chiral center. Is that very simple? You just see the slide. From this you can locate which one is going to come as a higher priority. For example, I will tell you here. I have shown here the first table iodine. This atomic number, first point of atomic number is 53, the highest priority. Second is that bromine is a 35, chlorine 17, thiol 16. First atomic number you have to check. Okay, then OH, that is an 8, NH2 group 7. So in the case of carboxylic group, you can check it out here. C double bond O, then OH. Okay, C double bond O and the OH. That indicates that a carbon is attached to double bond means two OH, two oxygen group. Okay, then followed by one hydroxyl group. So that I have represented here. 6 is connected to 8, 8, 8. That means what? 6 is connected to oxygen, oxygen, and oxygen because of double bond. Similarly, you can see that now C double bond O NH2 group, amide group. You can check it out here. Carbon is attached to double bond, correct? Double bond O. That means you have two oxygen. Okay, then one amide group, NH2 group. So that is a nitrogen. That's it. Now 6 is connected to 8, 8, and 7. That you have to consider. Then formaldehyde. That's an aldehyde group. That's the what? That's an aldehyde group. C double bond O H. See that now here 6 is connected to 8, 8, and 1. That means what? Two oxygen. One is a hydrogen. Understood. Similarly, you can calculate for CH2Cl. Here you have to concentrate mainly on carbon is connected to the functional group here. Chlorine is a functional group 17. Then thiol group. Next carbon is connected to 16. Then oxygen group, alcohol group, CH2OH group. Carbon is connected to H. Similarly, C is connected to N7. So similarly, you can calculate hydrogen is equal to 1. You before to go for this assigning that priority, you should must know this table. So thoroughly you finished up thoroughly, but it is very simple only, easy to remember also. So keep it in your mind. Second is that I will plan to discuss. There are totally 16 examples. Okay, for exam point of view, I prepared only 16 examples. That is more than sufficient for JAM examination. Okay, similarly you can see that now here example number 1. So what I have told and what I have told here is that how we are going to assign. See that now molecule right hand side I have given an organic molecule. Chiral center is a stereocentric molecule is here. So how to do that now? You know the rule now. Con in gold rule. What is the rule? I says that now according to atomic number. First point of atomic number. So that's it. I represent here. Priority of group depends upon the atomic number of the atom attached to the stereo center or double bond. Higher the atomic number of attached atom, higher will be the priority of the group. Similarly, one more point also note. Point also is a note. One more note also you should must know that here the type of three dimension. You see that now here as type of molecule. If you are going to see that now, if the hydrogen on wedge, this is a wedge bond. There are two different bonds they would represent in examination point of view. One is a wedge bond. Then is that next one is a dashed wedge. That is we are a dashed bond. Okay, if the hydrogen on wedge, you have to take care much. If the hydrogen on wedge, opposite configuration you have to report. That's it I represent here. If the hydrogen is on dashed, so no problem at all. So as it is, whatever configuration you are getting, that you have to represent directly. But if the hydrogen on wedge bond, what is that? Opposite configuration you have to report. So that's it. I have given one example here. So mainly you have to look into that. Then here bromine is there, chlorine is there, the CH3, but hydrogen is on dashed. So no problem at all. So whatever that point, directly you can represent now. Here what is that? Bromine carries 1, and then followed by chlorine, second atomic number, then carbon 6. Then hydrogen is last 1. So 1, 2, 3. That means what actually this is an anti-clockwise direction. If you are going to, if it is an anti-clockwise direction, you are going to represent S configuration. If it is in clockwise direction, you know how to represent. There is an R configuration. That basic point you know. That's it. I didn't touch that basic point here. Directly I was going for examination point of view. Okay, so now the hydrogen is on dashed bond, so no change. So whatever that configuration you are getting, that is as it is you have to represent. Example number two. Sometimes they will give including some isotopes. Sometimes they may give isotopes. That time you have to take care. So three main isotopes only you have to highlight. We have highlighted here that you have to take care. That is what the main isotope. Highest is this H3, tritium. Deuterium you know that H2, then protium H1. So you can see that now example number one. Instead of one methyl group, I have one hydrogen is replaced with D. That is nothing but deuterium. At the time, what will happen? What is the configuration here? OH, that's a hydroxyl group, oxygen. Okay, first atomic number, oxygen. Okay, then followed by deuterium, CH3. Both side CH3. Imagine that both are CH3. One side is that one hydrogen equals deuterium. That means what? C is connected to one. Here C is connected to two. Deuterium means what? Two hydrogens. Okay, two more hydrogens are there. So that is very very important. Now that point you have to take it here. Okay, similarly hydrogen, you can see that the lowest priority group, hydrogen, that is in dashed bond. So whatever the configuration you are going to get, that is as it is you are going to write down on the paper. Understood now? No. So now one for OH group, two for deuterium, second the three for a simple methyl group. Okay, that's for a four. So is that automatically you know that now is a clockwise direction. So is an R configuration. Example number three. If the example number three, you can check it out here. What is that? I plan to represent one chiral center I have highlighted. Okay, the star mark I have represented in the slides, that is indicated chiral center. If there is a tie, see that now here is easily can assign. You can easily assign when there is a tie. You can say that, check it out here. Now one hydroxyl group is there. One. Okay, no problem at all. Next chiral center. What is that? Four groups. One is OH group. Then bottom one hydrogen is there. Left CH2. Then CH2. See that now CHH. That's it. I represent here CHH. Then one right hand side also CHH. That means what? CH2 group is there. So that means what type? So now we are going to give how I am going to give a priority. So you are going to move that to the next carbon. That's it. I represented here. Compare all atoms bound to each. Continue until the first difference. Then assign the priority. So according to that rule, I am going to move to the next level. So left hand side, you can see that now here the CH3 is connected to chlorine group. That means what? Highly electronegative group. Okay, so that I'm going to give that periodic number 2 for the case of chlorine attached to methyl group. Right hand side, you can see that now CH2 is connected to CH3 group. That is a very simple, that is a simple methyl group is there. So I am going to give for priority number 3. Hydrogen is on dashed line. So no problem of taking care. Whatever that configuration I'm going to get, as it is, I'm going to write down. So accordingly, one carries OH, the chlorine attached to methyl group. Then second, third one is that methyl group attached CH2. Then fourth one is that hydrogen. So accordingly, you are going to get now anti-clockwise direction S configuration. Example number 4. So I want to represent that very simple example of double triple bonded with the carbon and as well as the nitrogen bonds. So accordingly, I have told that now in the first slide itself, if it is the C triple bond to C, that means what? Three C's are there. C, C, C. Similarly, CH2, CH, that means what? 2C, 1 hydrogen. Similarly, you can see that up here, double bond N, that means what? 2 nitrogen, 1 is a hydrogen. Okay, yeah. So according to that of atomic number, who is going to take the number 1? NNH takes the number 1, followed by CC, then followed by CCH. Okay, see that example number 4 is a very important jam question actually. This one, see one carbon is that the star mark. I already told that now this is a chiral center. We want to know the configuration of exact that particular center. So how to do that now? Left you can see that now double bond N is there. Then right you can see that now triple bond, then double bond. So who is going to come take the position of one? Nitrogen, because I electronegativity, nitrogen takes the position 1. So CCC, next one, 2, then followed by CCH. Okay, so accordingly, so after assigning, just you can check it out here. Is it clockwise direction or anti-clockwise direction? This is a no doubt. It is an anti-clockwise direction. What is that dashed line? That is at the lowest priority group, the fourth group, lowest priority group on the dashed line. So lowest priority group, whatever with it, maybe of hydrogen or maybe of CH3, whatever with that lowest priority group, must it is there in the dashed line, no problem. So whatever the configuration you are getting, finally can depute the same. What is that? Is that anti-clockwise direction? So we are assigning yes. Now we are moving to the next very important topic actually. Assigning there's a two substituent on an atom differ. only in their absolute configuration. For example, you can see that now there are three chiral centers are here. I need that configuration for center. That is the center of a center molecule, the center carbon. That is that center carbon only. I want to know that configuration. See that now right hand side also same thing, left hand side same thing. Both are same substituent. So accordingly, in what way I can take? So in what way I have to give the priority? So you can check it out here. Need for second right hand side star I marked actually. The second side you can check it out again. Locate the configuration. So left hand also is just locate the configuration. What is the configuration for right hand side? Right hand side configuration is R. Left hand side configuration is S. That particular chiral center is having R. Left is that S. I want to calculate the center of the carbon configuration. So how we are going to periodize? That's number one. So how we are going to give that? R always takes a priority. Because both are same. R you can take. Okay, R configuration takes the priority followed by S configuration. So accordingly, you can see that now the OH group number one. Next is that R substituted, that is R configured chiral carbon. Okay, takes a position number two. Then S configured chiral carbon is three. That means what? According to similarly, that the hydrogen is no chromatal. It is in a dashed bond, so no chromatal. So there is that right, there is that clockwise direction. Because of clockwise direction, we are substituting. We are giving that the R configuration. Okay, this is very important topic that you should must know that now regarding exam point of view. Similarly, I plan to take one example of ring systems. How you are going to assign that R and S configuration for ring system? See that the first example you can check it out here. The first chiral center CH3 group attached with wedge bond. Hydrogen is attached by a dashed bond. That particular carbon I want to configure it. Okay, so I want to one more two group. What are the two groups? CHH. The right hand side of the CHH. So that means what tie? So tie is in what I told actually. According to the rule, you have to move the next carbon up to getting the point of difference, first difference. Okay, now I'm going to the next. Left hand side you can see now CHH. Right hand side you can see two methyl group is. That means what? CCC. So who is going to take the position number one? No doubt at all. Carbon, carbon, carbon. CCC that takes the position number one. Then followed by CHS2. Then followed by methyl. Then followed by hydrogen. Hydrogen is untouched. So no problem at all. R configuration is that clockwise direction. Keep move around the ring up to getting the point of difference. Is that number one? Is that R configuration? Next, you can see that now here bottom portion. You can check it out now. Two chiral center within the ring. Two chiral center is here. So I want to locate first one. See that now one chlorine takes a dashed bonds number one. Then who is the number two? The second position I have shown here is now that is attached to bromine. Right hand side attached to bromine, left hand side attached to CH2 group only. So that particular chiral, okay, top chiral, the second portion goes to attached bromine, methyl group attached to bromine. Left three. See what is the three position? CH2, CH2. So no problem. Then followed by fourth, but four. Take it out four. For the least periodic group on wedge bond. That means what? The configuration, whatever the configuration you are going to get, that you just reverse it. Okay. So what is that? Actually, you are going to get now R configuration, but because of hydrogen is on wedge, it is a S configuration. Similarly, you can check it out here. Second chiral center, bromine carries number one, no doubt. Second group where see the now bottom left CH2 is there, but top bottom upper part you can say now CH2, then Cl chlorine group is there. So that carbon takes a second position. Third carbon CH2 is a simple methyl group. Okay, followed by hydrogen, but hydrogen is on dash line. So whatever you are going to get configuration, that same you are going to put on the paper. So this is a S configuration. Anti-clockwise direction is an S configuration. 1, 2, 3. There is an anti-clockwise direction. So hydrogen is on dash. So no change as it is S only. Now I'm going to tell you, I'm going to educate you how to convert simple Fisher formula into Bote formula. Okay, there is also one type of giving the very easy way of representing that R and S configuration. So always already we have educated you horizontal wedge. Okay, horizontal means wedge. Vertical means what? Broken wedge. Okay, that indicates what? Wedge means what? Out of plane of paper towards front. The broken wedge means of going behind the plane of paper. Sir, how we are going to give a number? I will tell you that in the case of this particular example, example number 7, you can check it out here. COH group is here, CH3, OH and hydrogen. You see that now hydrogen is on a wedge bond. Hydrogen is on a wedge bond. Always one more point also you should must know that here. Okay, the horizontal bond always the wedge. Wedge means what? The lowest priority group must be there on the horizontal line only. The period lowest priority, that means hydrogen, whatever with the group, the wedge bond. Okay, the wedge bond always who must be there? Lowest priority group must be there. The lowest priority group bonded to the chiral carbon must always be shown as a horizontal bond only, irrespective of the representation. So, according to the rule 1, 2, and 3, rule like an R configuration, but hydrogen is on wedge bond. That is a horizontal line. So, opposite configuration results. So, is an S configuration. Understood? Similarly, example number 8, you can check it out here. I'm going to take an example of glyceraldehyde, R plus and R minus, R plus or R minus, R plus or minus, or R and S. How we are going to allocate it? So, now here I have located the chiral center by way of arrow. Okay, sir. Then I'm going to assign that priority. Now, OH group takes a priority. Right hand side, aldehyde group is a second priority. Left hand side, CH2 OH. So, CH2 is the number one. So, CH2 is there. So, third priority followed by hydrogen. But hydrogen is in dashed line, so no problem at all. There's a, automatically it carries in a clockwise direction. So, R configuration. So, right hand side, you can see it's now R plus. Okay, no problem at all. Here, you can check it out here, chiral center. But hydrogen is on wedge bond. That means what? Uh, Actually, you are going to get R. If the hydrogen is on wedge, it is a reversed. That's a replaced by S configuration. Okay, so glyceraldehyde I have represented the two different R and S forms. Depends upon the bond, wedge bond. Okay, that is a point you should must know here. Similarly, how to translate 3D formula into Fisher formula, three-dimensional formula into Fisher formula. I have represented 3 points. What are the points now? Lowest priority group must be on horizontal. Already I told that now. Lowest priority. Don't bother about that. What are the molecules they given in the exam paper? Don't bother. You just take the lowest priority. For example, if the hydrogen is lowest priority, keep it on the horizontal position. That's all. Then what about the rest? You can fix whatever with it. Maybe left, right, whatever with it you can fix according to our wish only. That's it. I represent. Then we can fix other atoms of our wish. Or I see that now accordingly I fixed actually 1, 2, 3 I'm getting. So 1, 2, 3 I represented according to the first atomic number. Then check it out with that is that R configuration. R means what? Clockwise direction. But hydrogen is on what actually wedge bond, horizontal bond. So you're going to report opposite configuration. Yes. So one more, sir, is it possible so for that you can do like this only, or no need to convert directly into Fisher formula. Directly you can also do it. That is called a name called by using the method name called the double switch method. What is the double switch method? So why instead of wasting time three dimension to Fisher formula, directly you can do it by double switch. What is double switch? What double switch is nothing but what actually interchanging of two times interchanging. During interchange, keep it in your mind that the lowest priority group must be, if it is there, not must be, if it is there on the dashed bond. Accordingly, you have to interchange. Okay, so that means what actually you can retain the originality without any change. Understood? So accordingly, you see now interchanging the group. Now first interchange hydrogen and COOH. My main idea is that hydrogen I want to bring into the upper dashed bond. So I have converter now. Dashed hydrogen is the next inverter. Next, one more interchange, two interchange. That's it. We are going to double switch. Two interchange, one more interchange. According to your wish, you can do interchange of OH and COH. So what will happen actually here? I have tried. Then accordingly, I have periodized the molecule. So 1, 2, OH is always 1, COH to then 3, C is the group. But hydrogen is on a lowest priority group is on the dashed. So as it is, retains the originality. As it is your right hand representation. This is a clockwise direction. So it's at the R configuration. So similarly, I represent the case of glucose molecule. Just for an example, I have shown here glucose molecule. How to represent this? Because I am going to educate you now for two or more chiral centers. For example, I have taken D plus glucose. How to represent that? How to represent now? Horizontal bond wedge. The vertical is a dashed. Okay, so you will concentrate mainly on a wedge. Wedge only. You have to take care much. Okay, so I represent only wedge bond. Then one more point, by looking into the two or three more chiral centers, two or three chiral centers, one more point also you should must be able to know that for identification of chiral and achiral, how to identify chiral and achiral. If the one half of the molecule is mirror image of other, that is we are calling as achiral. That's the thing about what plane of symmetry. Okay, plane of symmetry is there na achiral. Plane of symmetry is not there na chiral. Okay, half of the molecule is mirror image achiral because of plane of symmetry. Okay, that very important. If the molecule is having 2 or 3 chiral centers, okay, you just identify chiral or achiral. Okay, based on a plane of symmetry. That is very important. So then automatically, if you know the two rules, what are the 2 points? Horizontal wedge. Second point, plane of symmetry. If you know this 2 point, automatically very easy to allocate for 2 to 3 chiral centers. Now we will take out the example of this one. 1, 2, 3, 4. I highlighted now. First carbon aldegate, second 3 and 4. I want to calculate R and S configuration for C2 and C3, carbon 2 and carbon 3. Automatically, you can check your look at here. OH group takes a position of 1, aldegate second, then followed by CH OH 3 is that anti-clockwise direction. So S configuration, but hydrogen is on wedge, so R configuration. Similarly, right hand side also represented similar examples. Example number 14. Enantiomers. Most of the time they will ask you that enantiomers. They will give 2 or 3 molecules. They will ask you to locate what is enantiomer, which are the molecules are enantiomers. They are asking to identify. Okay, enantiomers are non-superimposable mirror images and have opposite configuration at each and every chiral center. Okay, so non-superimposable mirror image. So I have taken one molecule. I have taken mirror image also. So non-superimposable mirror image. Okay, opposite configuration each and every carbon. See that now I taken C2, C3, right hand side C2, C3, you can check it out here. C2 carries 1, 2, and 3. That means what? Clockwise direction, but hydrogen is on wedge, so C2 is carries S configuration. C3 again same S configuration. Right hand side mirror image, you can check it out here. Bromine 1, that's the second bromine down, 2, then upper side methyl group. So 1, 2, 3. This is a S configuration because of hydrogen is on wedge, is an R configuration. That means what? C2 left hand side is S. Mirror image, right hand side you can check it out, is an R. That means what? Is the enantiomers. Second chiral center, C3, you can check it out. C3 is left S. After mirror image is R. So those molecules we are calling it as enantiomers. Clearly, I have represented here. Take the mirror image, each chiral center, it's a different configuration. That's nothing but opposite configuration results. Those molecules called as enantiomers. What is diastereomers? 1 point. Only 1 point you should must know the term. One chiral center must be identical. That's all. Diastereomers means one of the chiral center is identical. Two isomeric structures with more than one chiral center having same configuration, at least one chiral center and opposite configuration at the rest of the chiral center. Check here, bromine 1, below bottom bromine is 2, above methyl group is there. So 1, 2, 3 is at the anti-clockwise direction. Hydrogen is on wedge, so I am representing R. C3 you can check it out, yes. Similarly, right hand side of molecule you can check it out here. C2 yes, but C3 is yes. That means what? C3S, C3S is there. C2R, C2R, okay, no problem at all. C3S, C3S, that means that particular C3 carbon is identical. So those molecules we call as diastereoisomers. Okay, so similarly I have represented here the R and S configuration in the case of most of the examination they will ask the tartaric acid as an example. So D plus glucose, I represented here D minus glucose, so D plus tartaric acid, D minus tartaric acid, meso. One difference in meso, if you're using the word of meso, the particular one half of the chiral center is mirror image of other. Nothing but plane of symmetry mandatory. Plane of symmetry is a mandatory. Rest of things are same. See that now, for example, D plus tartaric acid, OH carries 1, COH 2, the CHOH 3. See that now 1, 2, 3. This is at anti-clockwise direction. Because of hydrogen is on wedge, I am representing S configuration. Okay, 1, 2, 3, anti-clockwise direction, but hydrogen is on wedge, so R configuration. Okay, so C3 is a R configuration. Okay, sir. So accordingly, you can represent. If planar symmetry is there, meso represent directly can write the is at the meso form actually. Okay, thank you, and my best wishes for you. This is a quick review. I think the quick review will be useful for your university examinations as well as the exam type examinations also. So thank you, listen. Thank you for listening. Thank you very much.